Why waste time in commute and spend lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in iit-jee? India's leading online NEET coaching 100% success iit-jee. At TeenEinstein, we focus on iit-jee coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.
Hello students, welcome to the PYQ discussions on JEE Advanced Papers. Here I have got a problem from JEE Advanced Paper 1 2023. So let us read this problem and try to solve it. A series LCA circuit is connected to a 45 sin omega t volt source. The resonant angular frequency of the circuit is 10 to the power 5 radian per second and current amplitude at resonance is I0. When the angular frequency of the source is omega is equal to 8 into 10 to the power 4 radian per second, the current amplitude in the circuit is 0.05 times I0, that is the amplitude of the current at resonance condition of the circuit. If the L or the inductance is given as 50 millihenry, match entry in list 1 with an appropriate value from the list 2 and choose the correct options given here. So the problem is from LCR series circuit, and LCR are connected to a voltage source which is an alternating voltage source, and the voltage is given to be 45 sin omega t as you see here, and peak voltage is V0 which is 45 here. Okay, peak voltage is 45. Okay, 45 volt. Resonant frequency is given as 10 to the power 5 radian per second, and at the resonance condition the amplitude of the current in the circuit is I0. See, the self inductance for the circuit is given as 50 millihenry, and at some other frequency which is not resonance frequency, the current in the circuit is given as 0.05 into I0. Now in the list 1 you have been given few parameters of this circuit, like amplitude of the current in the circuit at resonance condition I0, the quality factor Q, then bandwidth of the circuit, and the peak power dissipated at resonance condition, that is given in the list 1. So you have to find out the values from the given informations for this circuit, and you have to match with the values given. There are 5 values in the list 2. You have to match 4 among these 5 with the entities mentioned in the list 1 and see which one of these given 4 options is correct. Okay, so let us solve this. Let us solve for the first entity I0. In milliampere we have to find out. See, I have drawn this figure over here once again, and we know the parameters are given. See, in this case at resonance condition, you know, the circuit will be resistive. Okay, the impedance will be just R, that is the resistance of the circuit, but resistance is not given. So that is the point here. Here instead you have been given L and you have been given resonance frequency. From here you can find out C. See, we know omega naught resonance frequency is equal to 1 over square root of LC. So from here I can calculate the capacitance of the circuit since I know this omega 0 and L. So if you calculate it, you will be able to find out this value to be 2 nanofarad. Okay. Now R is not given, but anyway there is another information given related to this I0. See, at some other frequency omega, the amplitude of the current in the circuit is 0.05 I naught. So this value will be, or this information will be using for calculating this resistance of the circuit. So let us see at resonance condition what is the peak current. I0 is equal to V0 by R. So peak value of the voltage divided by resistance. Okay. So let us say this is equation number 1. Now at the given condition, see at the given condition what is the current? Current, let us say the peak value is I. So that is equal to V0 by Z. This Z is not R because now the frequency of the source is not the resonant frequency. Okay. That is some other frequency. Therefore this Z is not equal to R. But anyway this I is given as 0.05 I naught, which is I naught by 20. Alright. So this, let us write that to be equation number 2. See now, impedance we know at any situation, impedance of LC circuit, series circuit is given by square root of, see Z is equal to square root of R square plus XL minus XC whole square. If I know the self-inductance and the frequency of the circuit, I can find out what is inductive reactance, that is omega L, which is found to be 4000 ohm if we put the value of omega and L. Similarly, I have found out what is C. Now if I want to find out what is capacitive reactance, I can find out that to be equal to 1 by omega into C. Omega is given and C is this one. Okay, see 1 over C is 5 into 10 to the power 8. Okay, you will be able to find out that. Or we can directly write here 2 into 2 nanofarad also. Doesn't matter. So it is way of calculation. So you will be able to see that will be 6250 ohm. Now this difference I can find out XC minus XL or XL minus XC, doesn't matter. Here I am just taking square. So I am just taking XC minus XL, which is 2250. So let us say that is equation number 3. Now let us go here. See Z square, let us write. Z square means R square plus XL minus XC, that is fine. Again you know Z is equal to, see Z is equal to what? Z is equal to V by I, V naught by I. Okay, so that is what I have written here. So from here to here, this is V naught by I, and right hand side is written as it is. See now V0 by I, see this I is actually, I is given as I0 by 20, that I have written here in the equation 2, right? From equation 2 I can write I is equal to I0 by 20 for the given frequency. Okay. Again what is I0? I0 is V0 by R, that is the amplitude of the current in the resonant LCS circuit. If I write that, then I will be actually arriving, okay, that this equation. Okay. Now look here, this value we know 2250, and this, see this R square, if I subtract 1, this actually this compared to 400, 1 is not that big number. So for the sake of calculation I am just considering this equation to be 400 into r square is equal to this. That means this one. So from here we will be able to find out what is the resistance of the circuit. That is, this will be something like this. Alright, so this is, now things are easy. See, once I have found out the resistance of the circuit, now I0 will be V0 by R. Okay, V0 is given as 45 and this is 225 divided by 2, so it will be 45 divided by 225 into this is this. So now this is 9, 5 4s are 20, then this, again this will be 5, then you know this is going to be 0.4. This is in ampere, so in milliampere it will be actually 400. Okay, so in milliampere this will be 400 milliampere. Okay, now let us see the first option and match it. See, in milliampere, so third, so P is matching with 3. Okay, now we'll just look for this quality factor of the circuit. We know, so here you have to actually use the formula quality factor, that is omega naught resonant frequency L into L divided by R. Okay, so omega naught is given as 10 to the power 5. This is 50 into 10 to the power minus 3, and R I will be writing 225 divided by 2. 225 divided by 2, so 2 I am writing in the numerator. Okay, if you solve it, this will be simple number. So omega 0 L will be in the unit of ohm, this also will be in unit of ohm, so it will be actually a number. Okay, quality factor is a number, both are having unit of resistance. Okay, so that's why it will be unit place quantity. So this is going to be 44.4. Okay, you can do the calculation and find out the value. So I have got Q quality factor. Look, this quality factor is matching with the 1. Okay, so this is matching with this matched with this, so I'll write here Q is matching with 1. Okay, now let us find out the bandwidth. See, there is a relation between bandwidth and quality factor. So bandwidth is equal to omega naught by Q, resonant frequency divided by quality factor. So you know this, so this will be rad per second. Quality factor is a number and this is radian per second, so this will have unit radian per second. Okay, so you can now write down this 10 to the power 5 and this quality factor. You can actually, in between this calculation, this factor you will get 400 divided by 9. Let us write this here, that will help you to find out this value and make your calculation easy. Okay, so 9 here. Okay, so ultimately if you do this calculation, you will get 2250. Okay, and this will be radian per second. Alright, so look the options. So bandwidth is matching with this one. Okay, so R is matching with 4, and doing this calculation, last option, the peak power dissipated at resonance will be I0 into V0. Okay, or V0 I0. So this is the peak power at resonance. Okay, V0 is 45, I0 we have got 400 into 10 to the power minus 3. Okay, so this will give you actually 18 watt. Okay, so look here in the options. See, this is matching with option 2. Okay, that means you know S is matching with 2. I'll check P matching with 3. Where is that? P matching with 3, Q matching with 1, R matching with 4, and S matching with 2. Okay, so option B will be the correct answer for this question. Thank you.
Why waste time in commute and spend a lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. iit-jee. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.